here's what I'm really here to sell you today. We need to rationalize the denominator. Okay, when you say rationalize the denominator, it's just a fancy way of saying get rid of the radical in the denominator. Rationalize the denominator, get rid of the radical in the denominator. If it said rationalize the numerator, it would mean get rid of the radical in the numerator. Okay, these problems will trip students up. Not the first one, not the second one, but when you don't have square roots in the denominator, it'll trip you up. So pay attention to the method when we have square roots and when we don't have square roots because they differ slightly. Okay, in part A, if I want to get rid of the radical around the 8 in the denominator, then I could multiply that entire fraction by a special form of 1. But even before I do that, I would recommend simplifying the radical 8 because it's not in simplified form, is it? So even before you get rid of the radical, if it's not already simplified, I recommend simplifying the square root of 8. 8 is really 2 squared times 2, right? Or 4 times 2. So if you pull out that factor of 4, I pulled it out in the form of 2 squared. What can I pull out front of that radical in the denominator? What's the square root of 2 squared? 2. So another way to write the given problem, you can write it as 3 divided by 2 root 2. But you're still supposed to get rid of the radical in the denominator, and we haven't done that yet. We've just made the radicand smaller, which is nice. Okay, so what could you multiply radical 2 by to get rid of the radical? Have you guys noticed this? That if you multiply the square root of a times itself, you get the square root of a squared if we use that property that says you can combine. It's the square root of a times a, right? If we use that property that says you can combine under multiplication, you can make one big radical and then multiply the radicands. The square root of a times itself is the square root of a squared, but what's the square root of a squared? A, as long as a is bigger than 0, we don't have to worry about absolute values. Well, that's the idea we're going to use here. So what could I multiply the square root of 2 by to get the radical to disappear? Itself, yeah. But I have to multiply both the numerator and denominator by the square root of 2. So that because what am I really multiplying by when I do that? I'm really multiplying by a big old 1. So this is supposed to look like a big fancy 1, right? Kind of looks like a house or something. I don't know. Radical 2 divided by itself is really 1. So am I changing the value, the decimal value of this number? No. But I'm just going to be able to change the form. Okay. So now think about it. When you multiply by a fraction, you multiply straight across. Or when you multiply fractions, you multiply straight across. So on top, what do I get? I get 3 times radical 2. The best I can do is just write down the multiplication. 3 times radical 2. It's like multiplying x times y. The best you can do is write it down. You can't. There's no way to combine them like you would be doing if you were multiplying x times x or y times y. What about on the bottom? We get 2, this 2 out here, and then what's radical 2 times radical 2 going to be? Radical 2 squared, which is just 2. So that's that property. Radical a times radical a is just a, right? So, okay, what do we end up with then? 3 radical 2 over 2 times 2, which is 4. Everybody believe that? Now, the neat thing about numerical problems is you could check your answer. If you plug 3 divided by root 8 in the calculator, you better get the same decimal value as if you plug in 3 times radical 2 and divide by 4. So another one, this is also a square root. It's the square root of 5 divided by 6x. So there's a couple of different routes you could go here. If you'd like, you could split up the radical and then use the same technique I used in the last problem. So that would look like this. The square root of 5 divided by the square root of 6x. Then you guys tell me, what could I multiply numerator and denominator by? By the way, the square root of 6x is simplified. There's no factor that's a perfect square factor of 6, right? or of x to the first power. So it is simplifying. So then you go right to that method I showed you for getting rid of that radical. What would you do? What would you multiply numerator and denominator by to get rid of that radical? 6x. Just 6x or square? Yeah, square root of 6x. Yeah, both on top and on bottom. So that you're really multiplying by 1. Okay, so now multiply straight across. Tell me what you get. What's the square root of 5 times the square root of 6x? One big root. Everybody look up. What's the square, multiply straight across. What's the square root of 5 times the square root of 6x? Square root of 30x, yeah. Square root of 30x. Does everybody see why? You multiply the radicands, keep one big square root around the whole thing. Over just 6x, right? Because square root of 6x times square root of 6x is the square root of 36x squared, which is 6x. And again, we're assuming variables are bigger than or equal to 0 here. So that's it. There's another way you could have gone here. And you might see it done this way somewhere, so that's why I mention it. If you take what we were given to start with and work underneath the square root, then underneath the square root, so it's like if you combined in the original method I showed you, it's like if you combine these into one big root to begin with, which you could do under the rules that we developed here. So if you work within the square root, then you would multiply numerator and denominator by 6x. It really is square root of 6x, but it's happening underneath that radical. And you're still just multiplying by 1, right? It really is the same technique. We're just mathematically, we're making it look a little bit different. And then look, what you get on top, you automatically have, if you split up the root, you automatically have the square root of 30x, just like we said you'd get. And then on the bottom, if you split up the root over division, you get the square root of 36x squared, which does break down. The square root of 36x squared is the 6x. So you get the same thing doing it that way. It just looks a little bit different, and it might throw you off if you're not paying attention. So that's an alternate way to think about it.